is. Tucked away in the north of the German capital, it's just 4.5 hectares in size. But the lake's catchment area, the surface from which rainwater flows unfiltered into the lake, is over 50 times bigger. Hartmut Wassmann recalls the day that they first examined the lake.
We've worked with a lot of lakes, but we've never seen one this bad. That spring, after the ice melted, we took our first samples and found fish scales in the deep water. There must have been a massive die-off under the ice. We'd never seen anything like it.
When leaves and other organic material get washed into the lake by rain, bacteria starts breaking it all down. That process uses up oxygen. Once it's depleted, other gases form, like methane and hydrogen sulfide. That creates a layer of foul-smelling sludge. The water starts to stink. It's a problem that many cities around the world are dealing with. Just last year, the lake in Roshanara Bagh, a historical park in Delhi, was dredged at a cost of over €1 million. Now it's back to smelling foul again. And it's not an isolated case. Back in Berlin, the water in Schäfersee is roughly cleaned and then released back into the lake. To improve the water quality, they're treating it with calcium nitrate.
The idea of using calcium nitrate to fight odors isn't new, and applying it like this in a body of water is also not unheard of. But combining it with oxygen, that actually came about more or less by chance, and it had a huge impact. Schäfersee was the first place we really saw the full positive effects.
For over a decade, their small company has treated the lake using oxygen pumps and calcium nitrate. Large plastic containers are hauled to the lake's centre several times a year. They pump the chemical into the deepest areas over the course of a week. But calcium nitrate has a bad reputation. Frequently used in industrial livestock farming, it's known as a water pollutant. So how can it help the lake to recover?
We use very low concentrations in our process, well below the legal limits for drinking water. And the nitrate is simply converted into nitrogen gas by bacteria.
The company digitally monitors all the lake's data, and they're tracking information from other lakes they're also treating. Along the way, they noticed something else. The phosphorus levels in the lake were dropping. And phosphorus is the nutrient that fuels dangerous algae blooms. So they brought in Professor Thomas Neumann, a geochemist from the Technical University of Berlin. He and his team studied sediment samples from Schäfersee. They found that calcium nitrate was helping to bind the phosphorus and trap it in the sediment.
Also für den See ist es gut.
That's good news for the lake, because it has too many nutrients, especially phosphate, and that causes problems.
Und wenn dann ein Mechanismus da ist, der dann das Phosphat...
If there's a way to lock that phosphate into the sediment for years, even decades, that's a great outcome.
But that still means they're only treating the symptoms here at Schäfersee.